All right, I'm going to talk about quadratic formulas today. Hi, Amanda. I'm going to talk about how it works and what it is. First, we have to understand what quadratics are. Quadratics are simply polynomials where you have an x squared term, an x term, and a 7, or a number, I should say. 7 is the one in the first one. So like x squared plus 3x plus 7, 2x squared plus 6x minus 4, 5x squared minus 3 would also be 1. Those are quadratics. It's just that format. Often we call them trinomials, but again, they're 3-term with the highest order being 2. And what we're used to is factoring. So if I give you this one, say solve it, you can solve it by going, well, okay, this factors. All right? Then we can say, oh yeah, A or B has to be 0, so x minus 3 equals 0, and or x minus 4 equals 0. So the solutions to this one are 3. You add 3 to both sides, and then the other one, 4. And again, if you plug those into the original equation, they work. 3 squared minus 3, 7 times 3 plus 12, that equals 0. And if you plug in 4, 4 squared minus 7 times 4 plus 12, that also equals 0. These are solutions to the red equation. But there are times when quadratics like this do not factor pretty into answers like this, and they have fraction or decimal answers. X is 2.479. X is 14.3. So we have to have a method to solve it that way. Now, you can complete the square on anything. So what I'm going to do is set up a general form. I have a coefficient A in front of the x squared, I have a coefficient B in front of the x, and I have plus C. And I am going to solve for the quadratic formula. Now, most often in classes, teachers don't expect you to know how to derive it. So I'm going to kind of fly by this and just show you. First thing is I want to get it, if I'm going to put in the square, I want to get it here where I have x squared plus b over ax equals negative ca. And we realize when we square a binomial, and I just did it here, I squared x plus b over 2a. Because what that becomes if you square it out through these steps is x squared plus b over ax plus the product here. You notice I have x squared plus b over ax. I need a b squared over 4a squared. And then that would be equivalent to x plus b over 2a squared. So I erase all that, and I blow it all up, and I add b squared over 4a squared to both sides. And then I plug and chug with completing the square all the way through here. Taking the square root of both sides here, and then moving over the b over 2a. And in the end, what I get is this formula. This is the quadratic formula based on this equation. So if I use that on the previous problem, I had x squared minus 7x plus 12 equals 0. And I know the general form is ax squared plus bx plus c equals 0. And I know x equals negative b plus or minus b squared minus 4ac all over 2a. All right? First thing I got to do is look at this form and say, hey, what's a, b, and c? All right, well, I know this is 1. So a is 1. B is negative 7 because you know it's the plus sign on B, so it's negative 7. C is 12. And now it's an evaluation problem. Evaluate this expression for A, B, and C. So negative B plus or minus B squared minus 4AC all over 2A. All right. Now I just need to do some simplification. 7, negative 7 plus or minus. Negative 7 squared, 49. 4, 1, 12 makes 48. All over 2 times 1 is 2. And then this, x equals 7 plus or minus square root of 1 over 2, which is 7 plus or minus 1 over 2. Well, 7 plus 1 over 2 and 7 minus 1 over 2 are the two answers. 8 over 2 is 4. 6 over 2 is 3. And then again, we knew that. Those are solutions we have. But again, anytime we have an equation now, we can use this quadratic formula. So if I go to a new page, and I know this is a thing, let's use, oops, that's not the right thing. copy this. We'll get this to work this time. Alright, so let's try a different, more difficult one. One that doesn't have a nice pretty answer in the end. So let's use 2x squared minus 3x minus 7 equals 0. Alright? And I suppose this is a good chance to point out we wouldn't have to have an order. I suppose I could have started off 2x squared equals 3x plus 7 and had to move them over because you have to get it to match the general form ax squared plus bx. So I'm looking now. So now I define my a, b, and c. I think a is 2, b is negative 3, c is negative 7. Alright, so here I go again. I'm going to go quite fast for the sake of video. And every time you get b squared, it's got to be a positive number. You got to watch your signs. Alright, here I go. 3 plus or minus 9 plus 56 all over 4. Now this one's ugly. So the final answer here is 3 plus or minus the square root of 65 all over 4. And those are the two solutions. That is simplified. So x plus the square root of 65 over 4 and x minus the square root of 65 over 4. Do one more, call it a day on the video. And the lead coefficient doesn't even have to be positive. You can leave it whatever sign comes up. So what problem I'm showing now is this. Alright, so again, I get a as negative 2, b as negative 3, and I get c as positive 1. So again, negative, then b is negative 3, plus or minus b squared minus 4ac all over 2a. And I get 3 plus or minus 9 plus 8 all over negative 4. And I get x equals 3 plus or minus the square root of 17 all over negative 4. Again, this is quadratic formula. You have to set it up to match. You probably have to memorize it most often in your class, this. That's something to ask your teacher about. Good luck, keep practicing, have a good math day.